Okay, everyone, so since we finished our proportions test, we are now moving on to our new unit. Our next unit is functions. Okay, so first thing, let's go over some vocabulary. First, our x-coordinate is the first number in our ordered pair. It tells us how far left or right to move when we're plotting our points. So if it's positive, we're going to move to the right. Just like on a number line, all of our positive numbers are to the right. Same thing with our coordinates. If our x-coordinate is positive, we're moving to the right. If our coordinate is negative, that's a negative symbol there, then you're going to move to the left. Just like our number line as well. The other coordinate that we have is the y-coordinate. The y-coordinate is our second number in an ordered pair, and it tells us how far up or down to move. So if it's positive, I think you can probably guess, but we're going to move up, and if it's negative, we're going down. And that's going to tell us how to plot our points on our coordinate grid. Okay, so here's a coordinate plane. First, look here, we have our x-axis, it goes horizontal, and our y-axis is vertical. So when we plot our points, we're going to pay attention to both our x and y coordinate and move accordingly. So for A, our x coordinate comes first, right? So every ordered pair has an x and then a y. So our x for A is 2. So we start at 0, right in the middle of our coordinate plane. That's called the origin. Okay, so 0, 0 is our origin. Okay, then it's positive 2, so we're going to move 2 spots to the right. So 1, 2 to the right, and then 6 up. So we're going to go up 6 because it's positive, and we're going to plot our point right there. So it went to the right 2 because it's positive, and then up 6 because, again, 6 is positive. For B, we have a negative 1 in our x coordinate. So we're going to go to the left 1 to negative 1, and then still go up 1, 2, 3, 4, and there's our B. For C, we're going to go to the right 3, and then down 2 because it's negative 2. So there's C. D is at negative 2, negative 5. So first, since our x is negative 2, we're going to go to the left 2. So left 2, and then negative 5, you go down 5. So there is our D. The next two are a little bit trickier. They have zeros, and we want to be extra careful when we have zeros as one of our coordinates to make sure they're not accidentally placing it on the wrong axis. Okay, so 3, 0, and 0, 1 are our next two. So first let's do 0, 1 for E. So having a 0 in the x coordinate means we're not going to move left or right. So when we go to our coordinate plane, we're going to be right in the middle, right? But then it's going to say our y is 1, so we have to go up 1. So there is our E. F is kind of the opposite. It's 3, 0. 3 is our x, so we're going to the right 3, but then we're not going to move up or down, so we're just going to leave it on the x-axis. Hopefully that was a review of stuff that you have learned in 6th grade. Our next part of our notes, we're going to look at some definitions. So first word is a relation. A relation is any set of ordered pairs. Okay, so it doesn't have any rules. It's just any set of ordered pairs. So if we have this list up here of all of these coordinates, okay, that's a relation. They're just all different points thrown together. When we have a function, that's when we have specific sets of rules. So a function is a relation for which each value from the x-coordinate pairs with only one y. Okay, so for example, a function, if you have 1, 2, then you cannot have 1, 3, because this is the same x coordinate going to two different y values. Okay, so you want to make sure that your x coordinates only pair with one y value. If they pair with more than one, then it's not a function. So it's a relation with some rules, not just any set of ordered pairs. And we're going to see some more examples later on in our notes. So our last two vocabulary words here, a domain, is the x coordinate. Okay, and our range are the y coordinates. Okay, other words for domain: input or independent. Okay, other words for y or range is output or dependent. Okay, those are all vocabulary words that we're going to need to know. Okay, let's do some examples with some ordered pairs and different representations of ordered pairs. So, the first thing you need to know is that ordered pairs or coordinates can be shown in 4 different ways. So first, we can write them as ordered pairs, which is just a set of all the coordinates. Okay, or we can write them as a table where we have x and y values listed out. You can graph them like we did on the front page, or you can do what's called a mapping. And a mapping is pretty similar to a table. Okay, so we'll talk about those each individually once we go through them. So the first one, our ordered pairs. Okay, ordered pairs is basically just as it says. You're listing out every single point. Okay, no matter what, you're listing out all of them. And when it asks for the domain, you're looking for the x values of these points. So if we look at our first point, 4 is our first value. Then we have -5, 5, and 2. So our domain is 4, -5, 5, and 2. Usually people write these in order from least to greatest when they're being exact and precise, but for me, this is fine. We can just write them how they are. For the range, we have our y values. So here it'd be 2, 0, 12. And then our last one is another 0. Here's where we should follow some rules. We're not going to write another 0. If there's more than one of the same number, we just write it one time, not twice. So even though we have 4 y values, right, we have another 0, we're only going to write 3 because we have 0 twice. Okay, for our table, we're going to write our domain and range the same sort of way, following the same rules. Okay, so our domain is our x value. So we've got -7, 12, 6, 3, and then we have another -7, but I'm not going to write it because we don't need that one, right? We already wrote -7. Our range is our y values. We have -1, 8, 3, +1, but then we're not going to write that last 8 because we already have another 8. Okay, but you see how I wrote -1 and +1? Those are two different numbers. So if you have a negative version of that number and a positive version, you have to write both. Okay. For our graph, we're still going to write our domain and range, our x and y. Okay, it might be helpful to actually write your ordered pairs down before you write out your domains and your ranges. So I'm going to actually write down these ordered pairs. So this dot right here, the one I colored in green, is at -3, 4. Okay, I'm going to color code these just to help us out. This dot right here is at +1, +4. Remember, your x value is how far it goes left or right first. So your x is your horizontal axis. So pay attention to that because it matters what order you stick your numbers in. Okay, our next dot, I'm going to color it red. We're going to go with this one, is at 4, 1. Okay, see how these two are the opposites, but they're at very different places, right? And then our last one will be flat, is at 5, 7. So once I've listed out my points, it's easier to write my domain and my range, right? My x values are my domain, so I have -3, 1, 4, and 5, right? All the ones in this column. Then for my y values, I have a 4 twice, so I'm just going to write it once. I have a 1 and a 7. Okay, the last version or representation of different ordered pairs or relations is a mapping. So for the mapping, it's almost like a table, except for in the table, when we had two -7 values for x, we wrote them twice. In the mapping, they're only going to write them once. So there's no example here that shows that, except for actually, 4 is going to 4 and -1 is going to 4. See how they didn't write 2 4s in this column, right? They just put 1 4, even though 2 x's are going to that y value. So we just have to write things once. So our domain is just the first column, that's our x's. So it's -3, -1, 2, and 4. And our range is our y values in the second bubble. So we have 0, 4, and 7. Okay, back to this relation function idea. So it says, is a relation a function or not? Well, the answer is sometimes. Okay, it's not always a function. If you see this kind of Venn diagram, relations is on the outside because relations is a broad category. It covers a lot of different types of ordered pairs, where functions is a specific type of relation. So, for a relation to also be a function, your x's cannot repeat. Okay, so look at the x values and decide whether it's a function. We only care about the x values if they repeat. Okay, if y values repeat, that's fine. X values cannot repeat for it to be a function. So let's look at some examples. So it says shade in all the functions below. So we have to decide if they're functions, right? So the first one, we're looking at our x values. 36 and 25 both repeat. They're there twice. So this is not a function. Okay, we cannot repeat our x values. If we look at our second one, we have 0, 4, 6, and 8. All of them are completely different x values. So this is a function. For our mapping, if we look at our x bubble, the 6 is going to 3 and it's going to 4. So if we wrote that out as an ordered pair, it would be 6, 3 and 6, 4. So 6 is repeating for our x value, so that is not a function. Our order pair set, we have a -6 going to 37 and a -6 going to 10. So those are the same x values, so x's are repeating. That's not okay, not a function. For our table, we have all different x values. 1, 7, -4, -5 are all different. So it doesn't matter that all of our y's are the same. Our x's are all different, so this is a function. Our last mapping, 3 is going to 7 and 6 is going to 2. Those are two different x's and they have two different y's, so that is a function. Okay, if you're looking at a graph to tell if it's a function, one way that you can do that is something called the vertical line test. Okay, so if the vertical line test intersects the graph in more than one place, then it is not a function. Okay, so if we look at our first examples, we're trying to find the graphs that are functions. So I want to show you an example that's not a function first. So this one at the bottom, if you were to draw a vertical line, it's going to touch this graph in 1, 2, 3, 4 places all at once with that same line, so that's not a function. Okay, same thing with this one up here above it. When you draw this vertical line, not really good at drawing straight lines, but this is not a function. It's going to hit those two dots at the same time, so not a function. Okay, these two though, no matter where you draw the line on it, it's only going to hit the graph one time, right? It doesn't hit the graph more than once, so it's a function. Same thing here. You draw a straight line up, it's only going to go through one of the points at a time. So both of those are functions. Okay. To finish off, we're going to have some examples of how to find domain and range given certain values. Okay, so our first one, given the function y is equal to 2x minus 4, what is the range value? So remember, range is y, when the domain value is 4. So they're saying x is equal to 4. So we're going to plug it into our equation. So 2 times 4 minus 4. This would be 8 minus 4, which would give us a range or a y value of 4 when x equals 4. Okay, number 2 is almost the same thing, except for this time they're saying, what is the domain value when the range value is 10? So they're saying y equals 10 this time. So we're going to have to solve an equation. So we're going to have 10 is equal to 4x minus 2. Some of us are really struggling on our FBFs every week to solve our equations, so we need to try this one. Okay, remember we're going to use opposite operations. So to get x by itself, we're going to add 2 to both sides, and you get 12 is equal to 4x. Then our last step, you divide by 4 on both sides. Cancel those 4's out. 12 divided by 4 is 3. Okay, number 3. How many elements are in the range of the graph below? So the range is y value, right? So we want to look at these points and see what our y values are. So our first point's at -3, 4. Our second point's at 1, 4. My third point is at 4, 1. And last we have 6, 7. So it says how many elements are in the range? Well, our range has 4, 1, and 7, right? It's our y values. So we have 3 elements in the range, because one of them repeats twice. This 4 repeats. So there's only 3 total. Shade in the value that is not an element of the domain. So the domain is x. So what I would do is write out my points again. So my first one here is at -2, 4. The second one is at 0, 3. Next one's at 1, -1. That's one right here. And then our last one's at 5, -6. So then which one's not an element of the domain? So -2 is right here, so that one's out. 0 is right here, so that one's out. 5 is right here, so that one's out. So it's got to be 3. 3 is not part of it. Our last question from the we try. Shade in all the ordered pairs that can be added to the relation to keep it a function. So remember, to keep it a function, we want our x's not to repeat. So if we add 7, 0, we would have 2 7s, so we can't add that one, because then it would not be a function. Okay, we have no 6's in our x's, so we can add 6, 6, and it would stay a function, because it's not repeating any of our x values. 3 matches up with 3, so that one's out. We can't add that and keep it a function. -1 is fine. We can have -1 and +1, and it could still be a function. Our last one, -2, matches up with this -2, so that one's out. So we can only add those 2 points to keep it a function. Next, you're going to try the ones at the bottom of this page and the next page as a U-try. When you are finished, you need to get them checked before you can move on to the next activity. Okay, be careful with this one. It says shade in all the ordered pairs that if added to the relation would make it not a function. So it's kind of the opposite of number 5. Okay? Please take your time, double check, and then get it checked by me.